Well, you came back. Thank you. I thought I lost half of you, but you came back for video 3 of lesson 9-2. So we have one more proof to do, not quite as long as the other one. All right, so this last problem says an interior designer wants the center of a circular fountain to be equidistant from the corners of a triangular lobby. Where should he place the center of the fountain? So we should know that if we want to be equidistant from the corners, then we need to be on the perpendicular bisectors of these segments. And if we are dealing with the perpendicular bisectors of the segments, then we're dealing with what's called the circumcenter. Circumcenter. Okay? So what we have to do here is we need to find two perpendicular bisectors, and then we need to find their point of intersection. So this is not a proof, right? This is just working with generic coordinates to find this point, okay? So step 1. I think I gave you 2 slides for this problem. I'll do it all on here, but again, feel free to use both slides. So step 1, we're going to find 2 perpendicular bisectors. Now again, you have 3 choices, right? I'm going to use the following. AB and AC. The reason I want to use AB and AC is because it involves A, which is 0, 0. Now, because I'm doing perpendicular bisectors, I do want to change these coordinates, okay? So I'm going to change these coordinates to 2A and 2B, and then this to 2C0. So I hope that doesn't affect you too much here, but again, because I'm going to find midpoints, use the 2's. So when you divide by 2, it makes things easier. Okay, so let's find AB. And what I mean by AB, I mean the perpendicular bisector to AB. Okay, so to do that, if I'm using AB, I need to find the midpoint of that side of the triangle. So the midpoint of AB is going to be 2A plus 0 over 0, and 2B plus 0 over 0. I got ahead of myself because A's coordinates were 0. And that would be 2A over, pause, timeout, right? Not over 0, right? You add the x's and divide by 2. Add the y's and divide by 2. What am I thinking? So let's go slower. So 2A plus 0 over 2. 2B plus 0 over 2. And that's 2A over 2, which is just A. 2B over 2, which is just B. Right? So there's the midpoint of that side. So this is AB. Okay. And now we need to find the slope of AB and then take the opposite reciprocal, because, again, we're going perpendicular. So the slope of AB is going to be, again, I'll take the B's coordinates and subtract A's coordinates. So it's going to be 2B minus 0 over 2A minus 0. That's 2B over 2A, which simplifies to B over A. To take the opposite reciprocal of that, though, would be negative A over B. And there's your slope. So here's my point. Here's my slope. Now it's time to use point-slope form. Y minus B equals negative A over B times X minus A. We're going to distribute this slope. So Y minus B equals negative A over BX plus A squared over B. And then we need to add B to both sides. When I add B to both sides, it's a B over 1. I need to make it a denominator of B. So multiply top and bottom by B, which makes that a B squared over B. So really I'm taking A squared over B and adding B squared over B. Okay. Now this has a denominator B as well, so I'm going to put it all as one big fraction. So I'm going to do it right over here. So Y equals, so we're going to put the negative AX on top plus A squared plus B squared all over B. Okay. And we're going to hold off there. So that's the equation of the perpendicular bisector for AB, and it looks something like this. Boom. Okay, so I'm going to put that up here. So this is for AB. Y equals negative AX plus A squared plus B squared all over B. I'm going to pause and erase, and we're going to do, what I say, AC next. Okay, so I'm going to change colors. I'm going to use blue. So now we're going to find AC's perpendicular bisector. So first thing is find the midpoint of AC. So I'm going to take A and C's coordinates. So it's the X's, 2C plus 0 divided by 2, and the Y's, 0 plus 0 divided by 2. Awesome that I get to use the zeros, right? That's great. So that's 2C divided by 2, which is just C, and 0 divided by 2, which is just 0. So the midpoint here is C0. Perfect. And now we need to find the slope of the line AC. Well, if you look at AC, it's horizontal. So when you take the y's and subtract them, you're going to get 0 minus 0. The bottom is 2c minus 0. But again, if the top is 0, doesn't matter what the bottom is, it's 0. But now, what does this mean? Well, this means that if the original line is a slope of 0 horizontal, that means the opposite reciprocal of horizontal is undefined, which means you're going to be a vertical line, which means you have the equation x equals a number, and that number is going to be the x that it goes through. This line is going to go right through this point. So it has an x value of c. So the equation of the perpendicular bisector to AC is x equals c. Beautiful. And now we need to do our second step, which is find the point of intersection. We're going to do, I'll do in green maybe. We're going to find that point P by solving this system where you have y equals this and x equals c. So I'm going to erase this and we'll do step 2 together. Again, you have another slide to do it on. All right, so again, so step 2 here, I'm doing it in green. Now we're going to find the intersection of these two perpendicular bisectors. So we're going to find the intersection, which is going to be our circumcenter, which will be equidistant from the 3 corners of this triangular lobby. Okay, so because this is just x equals c, where I see x, I'm going to replace it with a c, right? So this is just y equals negative ac plus a squared plus b squared all over b. And that's all it is. We're done. Okay? So the point of intersection right there is going to be C, comma, negative AC plus A squared plus B squared all over B. And that would be the point where it would be equidistant from the 3 corners. All right, so hopefully you held on till the very end. I did want to mention that in the book, they did write this topic a little differently, so I'm going to do that real fast. So because the AC is negative, they actually put it last to make it look nicer. So they did, it would be A squared plus B squared minus AC. And again, just to emphasize what this whole section is about, is that this works for any triangle, right? So if I were to have any triangle of this form, right, and again, I guess it is a little specific because this must be horizontal, but nevertheless, right, if you had a triangle like this where you could position it on the coordinate plane like so, you would just need to know its A, B, and C values for its coordinates, plug it in, and you would have that circumcenter automatically. Okay? All right, thanks for taking a look at this, and good luck on the practice.